Alright guys, in the last video we left off with me time skipping ahead to the ADS, and as you can see I have it perfectly aligned to the middle, more or less. Could still use a little work. But now I'm going to teach you guys how to lerp the camera so it actually zooms in and out. And as you can see in the framework, we managed to lerp the actual camera, or the arms itself, so that they move smoothly and not teleport. Unfortunately, we can't do that with single number variables, which is what we're going to be using to make the camera zoom in. As you can see, field of view is just a single number variable. So the formula to lerp a single number variable is going to be camera dot field of view is equal to the original camera field of view plus what we want it to turn into. So we're going to add a new variable in our gun, because snipers and pistols and shotguns are all going to have different amount of zoom. Snipers would obviously have a lot more, and a shotgun would have not so much. So we're going to put zoom is equal to 50 for the camera field of view. So gun dot module dot zoom minus the old field of view, which is camera dot field of view, times how much we want it to go by, and since this is idle, we're going to go by 0.15. And also, since this is the original field of view, the idle one, we don't want that to be the zooming one. So what we're going to do is we're going to copy that and paste it over here and put it by the exact same ADST as the last time. Remove the extra parentheses, and this will make it so that the camera will be perfectly aligned at the same time the zoom is perfectly aligned, so not one is faster than the other. As for this, what we want it to be is the default camera angle, which is 70. And if we hit play, it should zoom in every time we aim in on the gun, and it should zoom out every time we let go of our aim. As you can see, it's working. That's a lot closer than we were before. And now you can see my angle is really messed up, so I will have to change that later, but we're going to leave it as is for now. And if you are following my gun specifically, these are my settings that I have so far. Anyway, if you were getting animation errors at the end and you didn't read the description of the last video, the thing that was giving you the animation errors was this part of the script. At some point, if you're copying exactly everything I did, I had this as gun idle and not idle arm. And the same over here where I'd mixed and matched the arm and gun animations, so all I did was simply fix it, and that fixed the animation completely. So if you're like playing the aim animation twice and it's going completely off center, that's what your error's coming from. Now in this video we're going to teach you guys how to make the crosshair so that we can actually see the spread of the gun. And after that we're going to start the ray casting to make bullets. So first we're going to need a new screen GUI. We're going to call it main. And now we're going to insert a couple of frames. And I'm going to make my frames to be 70 by 10. 75 by 10. And you make 4 of them. And we're going to need 2 to be the exact opposite of that. So we're going to put this as 75 and this is 10. Okay, so the vertical ones are going to be named up and down, and the horizontal ones are going to be named right and left. So up. Okay, for now we don't actually have to do anything with them. We're just going to unenable this. But we're going to have to create a whole new function to update the GUI. So add local function update GUI. Now, what we're going to want to do is make a minimum variable, so if the spread's really tight, we want the crosshair to go away completely. So if spread x is less than or equal to 30, or spread y is less than or equal to 30, then cross frame, which we need to make. So go up here, visual variables, local cross frame is equal to player GUI dot wait for child main. Okay. So cross frame dot left dot visible is equal to false. Cross frame dot right dot visible is equal to false. And cross frame dot up dot visible is equal to false. Cross frame down dot visible is equal to false. Now for if it's not invisible, we need it to be visible and in the right location. So first we're going to make them all visible. Just copy all these, paste it here, and set them all to true. And now we need to adjust their spacing. So cross frame dot left dot position is equal to udim2 dot new. And what we're going to be doing is we're going to be making the actual spread in pixels and not in absolute value. Because if it's an absolute value and somebody has a really wide screen, they're going to get a really large x-axis spread compared to everyone else. Whereas if it's in pixels, it's going to be the exact same for everyone else, no matter what size your screen is. So it gives no one an unfair or fair, just no unfair advantage or disadvantage. Which is why we're going pixels. So we're going to do 0.5, comma, spread x divide by 2 plus the size of spread x, which is 70, divided by 2, then 0.05, comma, 0. Since this is the x-axis, aka the left one, we don't need the y changing at all. And the same with the right one, except they're going the opposite direction, so it's going to be udim2.new negative, or 0.5 negative spread x divided by 2 minus 75 divided by 2, 70 divided by 2. Now the reason we have spread x and negative spread x is the value that changes every time we're zooming in or zooming out, which we're going to add the same way we did the camera. So depending on how long you've been scoping in for, it'll change how much spread you have. And the reason we add the 70 and subtract the 70 is so that um, it's accounting for the space of the actual frame itself. That's the bar that you can see. So everything, every single bullet lands inside of it. And that's basically it. And then we do the exact same thing for the up and down positions, except this time we're doing it for the y-axis, so this can be 0.5 and that's just left as O. And then for the up position, you want it to be negative spread y divided by 2 minus 70 divided by 2. And cross frame dot down dot position is equal to udim2 dot new 0.50 0.5 and then positive spread y plus the size of the frame divided by 2. And now we can enable this again, and if we have done everything correct, it should be at a consistent 0 spread, so it's going to be pretty tight since we haven't done anything with spread yet. Oh wait, don't test it without adding the update GUI, obviously. So Control C. And what we're going to want to do is we're going to want to put it after the change of field of view, because every time we're in here, we're going to be changing the spread. And every time we're in the aim, we're going to be changing the spread, and you want the spread to be updated after the change, not before it, otherwise it's inaccurate. And as you can see, everything has completely disappeared because the spread is 0, so we don't have more than 30 spread, and that sets it all to false. But say we gave the x-axis 80 spread and the y-axis 31 spread, and now you're going to see the x frames are wide and the y is not as wide. Easy. Okay, left, right. Nope. Hmm. Okay. So we need to change up the spread a bit because it is not working as intended. Alright guys, this is future me. I did a time skip to figure it out again. The first change I made was I replaced left with right, if you've been following along, because they were on the wrong sides. The second big change I made is where you had zeros here, it wasn't centered precisely correct. So what I did to counter that was I added the Y offset of the actual frame itself, which we need to change to right, although it would still work because they're both the same. But I mean, you could always have different size values, so make this left. And you're basically doing the negative Y scale of it divided by 2, so it aligns in the y-axis perfectly. And same with the left one. And we also did it for the up positions for their x-axis by making them negative for whatever size their x pixel size was, which is offset, divided by 2. The second really big change that I did in that time skip was change the formulas completely. So this would be example formula 1. This would be example formula 2. And formula 1 is basically subtracting it completely, and then Formula 2 is just adding it. So this is Formula 2, and this is Formula 1. So what Formula 1 does is, all it does is get the spread of it and divide it by 2 because it's already going to the right, so it's just adding. So if we were to add any more, it'd go too far. But for Formula 2, we subtract it to get the offset, but we also have to subtract the size of the frame to make it go even further. Otherwise, half of the frame's going to be inside the area that you can shoot in. And we did it over here too, where we did the negative offset, and then we also subtracted the size of the frame. But over here, we only did the offset, and we don't have to add the size of the frame because it's automatically past it. So if we hit play, it should be perfectly around the frame. And as you can see, not a single bit goes inside. Now onto the next step of it. What we're going to do is we're going to start adding the lerping of it. So as you can see over here, we had the spread X and the spread Y of it. We're going to make it a bit higher so that we can actually see it change and whatnot. Or actually, no. We're going to make this a bit lower. So we're going to make that 25 and 25. For the spread of the pistol, I guess we'll have it as 30 and 30. Let's make this 15. Okay, I like that spread. We'll keep it for now since we don't know what it looks like. And for the spread, we're going to do the exact same lerping thing we did with the camera, except this time we're doing it with spread X is equal to spread X plus gun.module dot spread X minus spread X again times 0.15. And you essentially do that exact same thing, but this time for spread Y. And what this does is it adds the lerping effect to the spreads as well. And it's going to be perfectly timed and change with everything else, with the camera view, with everything. Spread Y. I really cannot spell today. There we go. Times 0.15. And we can simply copy these, go down to aim, paste it in, and we're going to do the exact same formula we got for seconds over here, over here. If we hit play, it should start out big but get small if we aim in and disappear. So it starts out relatively simple, although it's not getting smaller. Let's go back and see what the problem is. Spread Y. Ah, I see what the problem is. We didn't actually change the spread of it. So what we want the spread to be when it's there, well, we're going to put 0.01 because if we put 0, we're going to get an error. But 0.01 is basically non-existent spread. It's literally half a pixel wide. So unless you're really going for a hardcore sniper shot, I don't think it's going to be a problem. As you can see, it gets smaller until it disappears. And now we can really see just how much I got to fix my gun. Anyway, that's the trick to crosshairs. Now we're going to move on to making raycast and how to make them random. So for the random raycast, what we're going to want to do is create a whole new function for it. So local function get ray, and we're also going to want to add a input thing, aka the spread of it. So the very first thing we're going to want to do is add local sense is equal to 100. This is just a variable that's going to calculate how many pixels it is for us, and we want to add 100%. The next thing we need to do is add local input x for the x-axis spread, and we're actually going to change this to new input x, and we're going to add another one, because you guys could always want your guns to have a different x spread and different y spread. Who knows? You could have like a made up 5-barrel wide gun. So new input x divided by 2.1, and local input y is equal to new input y divided by 2.1. Now, you can put it as 2 if you want it to be the exact same width, but I like putting it as 2.1, so it's just a tiny bit tinier than the actual thing. Anyway, after that, we're going to start making the right offset and the up-down offset. But first we need to get the actual screen size, so for that we do local screen size is equal to camera dot viewport size, which is basically the size of your window or screen, and we're going to divide it by 2, and then the local up-down offset, we're going to have it math.random negative input y times sense, and after that we're going to divide by it. Correction, we divide here. So let me get rid of that real quick. Bam. And after we do the negative one in math.random, we also need to do the positive one. So input y times sense. And that's basically just going to give us a random number between the negative or the positive spread. After that, we do it for the right one. So right off is equal to math.random negative input x times sense, and then regular input x times sense. Divide that by the sense, and there's a right offset. And now we're going to create the actual ray that goes in a random direction depending on your offset. So for the ray, we're going to do camera screen point to ray. Now we're going to get the screen size x plus the right offset, and then screen size y plus the y offset. And after all that, we return the ray's direction. And just like that, we created an array that works with our crosshair. So if it's 100, it's going to be 100 wide. If it's 200, it's going to be 200 wide. And now we need to start making the bullets for the gun. So we're going to add a new function, make bullet. And we're going to call it bullets because, like I said, we added that pellet variable earlier. So what we're going to do is we're going to have it cycle through how many pellets we have in a loop. And if it's 0, then it's only going to cycle through once. But if it's like 5, it's going to go through it 5 different times. And it's going to return a table. You're going to see the grand scheme of things later. So local hit obj is equal to false. That's a variable that's going to tell us if we actually hit any object or not. So local ray table, which is going to collect all our rays for our pellets, or just bullet, and local object table is equal to blank, which is going to be every single object we hit. So for the pellets loop, we're going to do for bullet is equal to gun.module.pellets. Our goal is 0, and we go in increments of -1. Do. So now we're going to make raycast parameters. So we're going to do it default Roblox style. Params is equal to raycast params dot new dot filter instances to character, and we're going to add a folder to workspace for later, or right now actually, but this is going to be used to store all the bullets, so bullets don't read other bullets as an object. So workspace wait for child bullets, and that's gonna make it so that it doesn't read anything on us or the bullets folder. Everything else is free game to hit. Also make sure you don't put actual raycast params there. After that, we're gonna add the param type, which is blacklist. I really cannot spell today. And now we get our direction, which we have conveniently from the function getRay. So is equal to getRay. And that's going to get our spread. We need to start inputting the actual spread.x, spread.y. And it's going to get our current spread x, current spread y. So if the crosshair is getting tinier and tinier, it's going to get the tinier version of it and not the big one. And local raycast result is equal to workspace.raycast. And we're going to actually shoot the raycast from the character's face and not the actual gun barrel, because not every gun's going to have a piece called barrel. But every character is going to have a face. So character.head.position in the direction. And this is where the range thing comes in hand. Because rays don't actually shoot all that far, and snipers are obviously going to shoot further than shotguns. So for a sniper, you could have like a 200 distance, but for a pistol, we're only going to have 30. So if it's anything further than 30, it's still going to fire a bullet, but it's not going to hit anything. It's just going to register as a no hit. So gun.module.range. And then also add raycast params. Not the real one. Here we go. Now, if we manage to hit something, then what we're going to want to do is we're going to want to table.insert into objects table the raycast result dot instance, which is the object to hit. And we're also going to want to insert into the ray table, if I can actually spell it, raycast result dot position, which is wherever the end spot was. That's where we're going to make, if you have like an RPG, that's where you'd make the explosion. But for me, I'm just gonna have a little black dot there, I guess, or little white dots like you saw at the beginning of the video, because that's what I like to do personally. But for you guys, you can make a decal or something at the end position. And we're also going to put hit object if hit object is equal to false. Then hit object is equal to true, meaning that we actually hit something. So after all of that, what we're going to want to do is if hit object is equal to true, then otherwise we're going to just fire. So this is where our networks can come into play, because we want this to be on the server. So now we're going to create a new variable for our network. So local remotes is equal to replicate storage, wait for child, network. Now we're going to come back down here, if we can find it. There it is. So if we hit something, we want it remotes dot create bullets invoke server, and we want it to fire off the array table first and then the object table. But we don't just want it to fire those, we also want it to fire our weapon type. So we're going to do gun dot weapon dot name, because if we do gun dot weapon, it's going to send it to the server as a nil object, because the gun we have only exists on the client and not the server itself, so the server's going to read it as nothing. But if we send the name, then it'll get the name 57, and we can just organize the server in that way. And the module script still exists on the server, so it can get all the information from the gun that it needs using its name, and only the name. So we're also going to want to add a new variable for local bullet register. We're going to call it false for now, because I'd rather it be false than false positive. So after that, we're going to put it in here. And same thing in here. The reason we have bullet register in here is because we're going to play of the flash later on the client, and we need to know if the bullet actually fired or not. And you could have an exploiter basically change their bullet amount to like 1,000,000 or a kajillion or the clip size. But on the server, it's not going to work. So what the server is going to do is it's going to return whether the bullet actually existed and if they were actually able to fire it. If they were able to fire it and they did fire it, then it's going to return true. But if they didn't have enough ammo in their clip, or they didn't have the gun to begin with and they were just cheating, it's going to return false, so the flash doesn't actually go off. So we're going to put this for now since we don't have the flash yet. So if bullet register is equal to true, then print it hits, else print we don't have bullets. Let's do that. There we go. Now we're going to start working on the server script. So we have the server script from the very last tutorial still in server script service. Now we can undisable it. So first we're going to want to get our services, so we're going to need quite a few for the server. So first, replicate storage as always. We're also going to need the players. We're going to need the network, so remotes is equal to replicate storage, wait for job. network. We're also gonna need debris for the game, so local debris is equal to game.getSurface debris. And we can also take that out of local, because I'm pretty sure I added it in there for no reason. Okay. That should be good. So, the very first thing we're going to want to do is not create the bullet yet, because we don't actually have anything to confirm if the bullet exists or not. So, we're going to do players.player added connect function player. If you ever did anything with leader stats, this should be pretty easy to you, or pretty common. If you haven't, then just follow along very closely. So, local file is equal to instance.new folder file.name is equal to gun info. We're going to call it guns info. Actually, no, I don't want to call it guns info. We're going to call it inventory. File.parent is equal to the player itself. Now we're going to create local primary is instance.new configuration, which is basically like a folder, but it's only for variables and no objects in it. So we can't put any folders and configurations, just variables, which is all we're going to need. So file.name is equal to primary dot parent is equal to the file. And then we're going to add some stuff inside primary. So local gun name, we're going to call this G1 is equal to instance. No, we'll just call it GN actually, because we can use the exact same thing. That new string value. So GN dot name is equal to gun name. GN dot parent is equal to primary. And then now we're going to have the clip value, so CV equal to instance dot new int value. CV dot name is equal to clip. CV dot parent is equal to primary. And then we're going to have the max ammo value, or stock value. Instance.new int value. SV.name is equal to stock ammo. SV.parent is equal to primary. Now we're going to create the secondary and the third slot tertiary. But we're going to call it third because I quite frankly don't want to spell tertiary. Configuration. Secondary.name is equal to secondary. Secondary.parent is equal to file. Local GN2 is equal to GN dot clone. GN2 dot parent is equal to secondary. Local CV2 is equal to CV dot clone. CV2 dot parent equal to secondary. Local SV2 is equal to SV dot clone. SV2 is equal to secondary. Alright. So then we make our third one, which is our final one. Configuration. Do all this because I'm getting bored of typing. Call that third. Copy this. paste that. And you can leave it like this. It doesn't matter that they're SV2 because it's still copying from the original source. So if we hit play, we should have the file in the files within our player as soon as we start. Inventory, primary, secondary, third. Clip, stock ammo. Okay, so we have clip and gun name, but we don't have the stock ammo, unfortunately. Alright, we're gonna play it safe and just copy this, since cloning seems to lead to problems. It's gonna take an extra couple of lines of code, but it's not too much to ask for. Third. Alright. So it looks good. We're also gonna add the names of the gun, or the value. So for this one, gn.value is equal to nil, or NA if you want. Some value you'll remember means doesn't exist. Okay, and then for the clip, we want their value to be 0 by default, so click here and here. And then lastly, the stock value, so SV dot value is equal to 0 by default. Okay, F5. Inventory, primary, secondary, has all of it. No errors, so I don't know why we don't have a third. Oh, we deleted it. It's parent, so third.parent is equal to player. This is why we test as we go along. Less pain later. Okay, now that we have that established, we still have some more work to do before we fire bullets. We're gonna need to make request a thing. So remotes.request on server invoke equal connect function player request type additional 1 and additional 2. Since this can vary from whatever the requests can be, it just gives us those extra slots. The only requests we're going to need right now is if request type is equal to add gun, then. And after that, we're going to need to add a new local function, so we're going to need to add 2 of them actually to make this really easy. So local function is equal to check for gun. We're going to need its file for the player and the name. So for blank comma slots in pairs file.getChildren do if slot dot name if slot dot gun name dot value is equal to name, then return slot. If it goes through all the slots and still has not returned, then it'll reach this point, in which case we'll return false, meaning there is not a gun, so there's not a gun slot to return. The reason this is important is so that we can't have duplicated guns. Like if you were to have guns bought off the walls or just guns picked up in general, and you only want them to have one of each gun, that's what that's for. It also checks which slot you're replacing. So like say I'm requesting to add a gun, and additional one in this case is going to be what slot I want it to be in. So I don't replace the gun with the exact same type for no reason. Or I know which gun I'm replacing on the server. So if request type is equal to add gun, then we're going to check if the gun is actually on us already. So if check for gun, and we need to add the file. The file is going to be local file is equal to player wait for child inventory. So we're going to send the file off to them, and we're going to send the gun name, which we'll call additional one, is equal to false. Then it means we don't have the gun already. Then additional 2, which will be the slot we want to replace. So local slot new slot is equal to additional 2 or file additional 2. And then after that, we have the slot we have, which if that had been secondary, it's going to be secondary. If it's primary, it's going to be primary. So after we have a new slot, we want the new slot dot gun name dot name to be equal to the additional 1, which is the name of the gun. New slot dot clip dot value, and we're going to go back up because we need to add something. We need to add local gun mod, which exists on the server, is equal to we're going to add modules up here as well. Go modules is equal to replicate storage wait for child modules. So modules additional 1, and we need it to be required so we have access to the information inside and not the file itself. So local clip.value would be equal to module dot we didn't actually put the ammo. Okay, let's start that. So clip, and this isn't going to change. It's just like the default clip, which you want it to be when, like, as soon as you pick up the gun. From a 5.7, I don't really know too much about guns, but I like the 8 bullet rule, so 8 bullets it is for me. You can pick and choose what you want. I'm also going to add a feature later to where you can make it unlimited ammo if you make it -1. So that'll be pretty interesting. Now we also need stock ammo, which is the amount of max ammo it has, so 80. So we have clip, stock ammo. So new clip, new slot.clip.value is equal to gun mod dot clip, and then we also need new slot dot stock ammo dot value is equal to gun mod dot stock ammo. So if we did this right, then we can request the gun and it'll load up into the settings. So what we need to do is we need to go back to our framework. We need to go down here and make it request the gun. So we're going to add if not gun then arms. So we don't have any arms, or we have this function return false. So what we're going to do is if add gun, then yada yada yada. Then it's going to check. If it's all good, This is going to set the settings and return true. However, if it's bad, we're going to return false, meaning we already have the gun. So what we need to do is go back over here. We're going to want to get the request gun. So remotes dot request invoke server, and our order is request type add gun. So now we need additional 1 and additional 2. Additional 1 is the gun name, and we don't actually need an additional 2, so we just need the gun name. So we already have the name loaded up into load gun, as you can see, which is convenient. So name, if it is equal to false, that means we didn't get the gun in the server, so we're not going to get it on the client. Then quarantine yield ends. So if we hit F5, it should give us the 5.7 on the server, unless of course it crashes just like it did now. I made a mistake. I was writing this like remote. I should have been writing this like a function. So go back to your server script if you haven't already. And when this says on server invoked, do not put .connect. What you do is you put is equal to function. And now it works. Okay. If not gun. Okay, so it sent the message and it ran the function, but it didn't get additional 2. So I accidentally put additional 2. I meant to put additional 1 here. Easy fix. Should run now. 5.7 is not a valid member of players. .cheatmcu.inventory. I know I did wrong. My bad. I did mean to put additional 2. Ignore me. I'm being dumb. We need this to be whatever slot we want it to be. So we're going to go back down here. And we do actually have slots, so I'm being really dumb that I didn't catch that. So slot. Easy fix. It's an adjustable everything. You can see how everything's building on top of each other. String expected got nil. String expected got nil. Dang. Okay, we need a. That actually reminds me, we need to make a fail safe. So if additional 2 is equal to nil, then we're going to get the next available slot. So additional 2 is equal to get any slot. So we're going to write a new function, get any slot. We do need the file though, so put that in there. For underscore comma slot in pairs file get children do. Actually, I'm not being all that intelligent right now. I can just use the same one. So let's do that. File, check for gun. And it's going to get the very first file that returns whatever you had your thing be. So for me, it was nil, so we're going to do the name as if it were nil. So it's going to return the very first nil one. And if I did that right, then it should work, and it's going to return whatever random gun we get. Although that's still not how I want it to work. Still doesn't work, weirdly enough. Got instance. Okay, I see what the problem is. So what we did was we got the actual direct file, so we need to make that name. Okay, now it works. Okay. So we go to players, we go to cheat MCU. It's going to be the very first one we got. We still don't have a third, weirdly enough. And see, the name is now 57. And we also have the stock ammo at 80 and the clip at 8. We need to make this be a value and not name though. So gotta fix that. Gotta name that name that value. And secondly, we need to fix why the third one is not showing up. So local third is equal instance.new third that player. Oh, I know. I put it in the player, not the file. Okay, there we go. Easy fix. Now, what we need to do for this is we need to actually give it a slot whenever we start uploading. That's always going to be primary, so load gun default. We can actually leave it as. We'll make a startup function later when the player spawns. Okay, now that we have all that though, we can finally move on to the rate casting. The part I'm sure many people are interested in. So first we need to do the remotes dot create bullets on server invoke is equal to the function or gain the player first, and we need to go back and check to see what we send exactly to the server. So back up here, bullet register. We send the gun name, we send the rate table, and we send the object. So name rate table object table. Okay. Now the reason I had you put else bullet register for this one, even though we don't have anything in the tables, is because I want this one to be called blanks, meaning you're firing off blanks basically, and blanks. That'll be very important. So the very first thing we need to do is check if we can fire the gun. So we're going to check for gun first. If check for gun. We need to get the file. Local files equal player. Wait for child. Inventory. So file and the name. If it doesn't equal false, then local slot is equal to check for file name, and we got the slot that way. Okay, now this is where the unlimited ammo and all that heebie-jeebie stuff is gonna come in. So if the slot dot clip dot value is greater than or equal to 1, or we also need to get the mod for this to make this work, because you can always glitch out guns and accidentally get into negative numbers. So that can also happen to the server. We can't accurately make assumptions that you have unlimited ammo. If you're in the negatives, you could have glitched it out through auto click or something like that, or just by hacking it to that point. But the one thing you could not exploit, no matter how hard you try, is the module script, because it doesn't even change on the client side, and the client cannot change it on the server side. So if we actually wanted unlimited ammo, it would have been called -1 over here, which is why we're going to get the module here to make sure it is actually unlimited clip or unlimited ammo. So local mod is equal to modules name. So, or mod dot clip is equal to -1. Then do that. So what this basically is checking for is if we have enough ammunition in our current clip to fire or not. So if we don't, then otherwise, else return false. And if we don't have enough ammo in our clip or it's in the negatives, it's going to return false and we can't shoot anymore, yada yada yada. So we're going to leave a note here if we have more than 0 bullets or infinite clip. So we're still going to do a couple more tests because we need to make sure, like, if you do have the infinite clip, do you have enough stock ammo to keep shooting? So if mod dot clip is equal to -1 and mod dot stock ammo is greater than or equal to 0, which is going to be our first variant, or mod dot clip is equal to -1 and mod dot stock ammo is equal to -1. So this means we have an unlimited clip and unlimited bullets. So unlimited clip or with bullets, or unlimited clip with unlimited bullets. So for this one, I accidentally put mod.stock ammo. We don't actually want that. We want slot.stock ammo.value. So we also forgot to put then, so put that there. And else if mod.clip doesn't equal -1, then. So if you're in this area, it means you have a slot clip value with more than 1. And in this version, if you do have the unlimited clip, you either need more than 1 bullet or you need unlimited bullets. So we actually need to add another else if statement. So else if mod.clip is equal to -1 and let's see. Oh yeah, never mind. We don't need this. This is just any else statement, so return false. Okay, so over here are the 2 instances where we're allowed to fire bullets and we can return true, so we're going to return true. Alrighty. So we actually need to start making the make bullets thing happen. So for that, where we don't have the actual fire mechanic yet, so we're just going to do it while we're aiming. So if gun.stays aiming, then make bullets. And it should either be returning on the client if we're firing or blank fire. Fortunately, it's not. Okay, first bigger. So filter descendant instance is not a valid member of raycast params. Let's see what we did wrong. Filter, I think it's a typo. Yeah, I forgot an S. It's a typo. My bad. Okay, now it should work. Now we attempt to index nil with head, so let's see what that's about. Ah, we never set a character. That's unfortunate. Okay, so what we need to do is every time we load the gun, we also decide to remake our character. So character is equal to player.character, because we can't load the gun with our character, so there we go. Wait for child is not a valid member of players. Let's see. Employee register, it's on the server though. So player.wait for child. Another typo. I really cannot spell today. Save our changes. Okay, hope with me that this is the actual one. It hit, it hit, it hit. So right now it's hitting because we're shooting close enough, but if we raise up, it should say it did not hit. No, it's still saying it hit. Okay, that's interesting. Oh, I guess it's returning if we actually have enough ammo to hit. So if we were to go to 5.7 and change it to 0, for instance, it means we don't have any clip ammo, and we don't have an unlimited clip. It should say it did not hit. We don't have bullets. Yep. Alright. Well, this video is getting quite lengthy, so I'm going to cut it off here and continue on to part 3 almost immediately, but I'm going to upload this section. In the next video, we're going to actually have the bullets hitting, and we might be able to get to the damaging of NPCs and the actual firing mechanic.